So another good GC question comes up, and that is, can you see water on a GC? So let me answer this in a couple different ways. First of all, in a GC, our predominant detector, our main detector, is the FID, the flame ionization detector. And FID cannot see water. Water does not have any carbon-hydrogen bonds, so therefore the FID has no ability to see it. So in the GC world, we have one main detector, FID. We probably have a dozen specialty detectors. So if you want to measure water, then you would have to use a TCD, thermal conductivity detector. TCD is universal, can detect any molecule in the world. I'll warn you about this one though. Water does not have a good peak shape. Water is very polar, obviously. It does a lot of hydrogen bonding, so it tends to give poor peaks, broad peaks, tailing peaks. But it can be done by GC. We could run water, but we need something other than an FID. So we need a thermal conductivity detector. One other comment I'll make is that water has a cooling effect on the FID. So even though we cannot see water with the FID, it does tend to cool off the jet, give us a little bit of noise when that happens. So if you're injecting large amounts of water and you have peaks that come off really early, sometimes we worry about, do we get good reproducibility in peak areas and that kind of stuff with early peaks because of that cooling effect of the water. In my experience, I have not found that to be a big deal. The cooling effect, I think it's fairly minor. It is there, but it's a fairly minor effect. So if you want to see water, get a thermal conductivity detector, and that will actually allow you to visualize it. So it is possible to do water by gas chromatography. Better way to do it, by the way, is just to do titrations. There's an easy approach out there that is used by most people. So I would probably avoid the GC and probably just go to titrations in order to measure water.